This time the shape is this. So we like to figure out the centroid of this shape. The coordinate system that they give us is one centered right here. And in this case, it's even easier because they're giving us those functions. They're telling us that this point here is 1 and 1, that this function is obviously y is equal to 1. We could have done that ourselves, but they're giving us this function as y is equal to x2. So it's a parabola. And we're trying to look for the center of mass. We know that the definition is two integrals on the top, squeeze an x for x bar, squeeze a y for y bar. And then we're going to use dy dx again because we're going to use vertical little rectangle. And on the bottom is just the area. So again, we have to identify those four limits of integration. Let's draw our little rectangle. I'm going to obviously start here, and I'm going to span towards the right. Add this one, add them up, add them up, add them up, add them up. I'm going to keep doing this until I reach this point. So, when we started here, the left side of the area, what was the value of x? Anybody? What is the value of x when you're on the y-axis? Yeah, excellent. Thank you. So let me zoom this, because really that's all we got to do. So therefore, x is equal to 0. Now, as we look at our diagram, what is the value of x for the rectangle that is on the right side of the shape? Yeah, it's given to us. Excellent. Bang. Done. Perfect. Thank you, Mallory. Thank you, Tyson. Now, what is the function from which we started to draw all those little stupid rectangles? What is the function from which we start to draw all those purple vertical rectangles? If you look at the graph. Yeah, it's right here, right? That's where we start. That's the function. Bang, x2. Now, what is the function that represents the limit where all our little rectangle end? Yeah, that's it. Problem is done. We can go home, have a beer. If you have a calculator, squeeze all this in your calculator, you're done. Very easy. If you don't have a calculator, let's refresh one more time our calculus. So let's go with the denominator. We just have to do this, right? So again, let's focus on the inner integration. As before, this is trivial. This will give us 0, what was that, 1? Yeah, 0 to 1, y, evaluate between 1 and x2, dx. As we evaluate the inner one, 0 to 1, we have 1 minus x2 times dx. Easy. We can integrate this easily. 1 becomes x. And x2 become x3 divided by 3. And we evaluated between 0 and 1. So we have 1 minus 1/3 minus 0 minus 0. 1 minus 1/3 is 3 minus 1 is 2, so 2/3. So 2/3 represents the area of that shape. Okay, now let's pick the x bar. So let's do the same thing, but let's squeeze a little stupid x in there. 0 to 1, x2, 1, and now we have an x, dy dx. Same situation as before. The inner integral is the dy. Therefore, as far as y is concerned, x is just a constant. We can take it out. this is the same as x dy, and then dx after. So we can do the integral very, very easy. It's just 1. Therefore, it becomes y. So this is y between 1 and x2. We can evaluate this easily. 0 to 1. This becomes 1 minus x2. So again, the only difference is we have an extra x tagging along. So now this becomes 0 to 1, x minus x cubed. Easy. The integral of this is trivial. We're going to pick up x2 divided by 2 for the first term and x4 divided by 4. We have to integrate this between 0 and 1. Therefore, this gives us 1/2 minus 1/4. Okay, not too bad. 2 and 2. 2 minus 1 is 1. So this is 1/4. Therefore, x bar is 1/4 divided by 2/3, or 1/4 times 3/2, or 3/8. So 3/8, if this is 1, we divide this by 8, and we go 3. So the x is going to be somewhere around here. Okay, let's do the y bar. We can keep this, no problem. And now here, instead of squeezing an x, let's squeeze a y. 0, 1, x2, 1, y, dy, dx. As we look at the inner one, now we need to keep the y, no problem, we integrate it. We keep the outside, and this becomes 1/2 y2 evaluated between 1 and x2. Okay, no big deal. We can do that easily. We evaluate this, so we're going to pick up 1/2 1 minus x squared. So this is where I believe this was called the shell method, this was called the disk method, or vice versa, I forget. But that's what they had us memorize. Well, really, as you can see, it comes from directly integrated the inner integral. Then we don't have to memorize anything. Life is easy. And I made a boo-boo. Should it be a 4 here? Yeah. Okay. So, next step, easy. We can take the 1/2 out, and then we can integrate the inside. So the first term will become x, the second term will become x5 over 5. And we need to integrate this between 0 and 1. Therefore, 1/2, 1 minus 1/5, minus 0 minus 0. So that's 5 over 5 minus 1 is 4 over 5. And then we can nuke one of the 2's, so 2/5. Therefore, y bar will be this guy, 2/5, divided by the area, which is still 2/3. So therefore, 2/5 times 3/2. And therefore, 3/5. 3/5, it means that we need to divide this by 5. Ugh. Okay, no good. So 1, 2, 3, 4. I'm cheating a little bit. And how many of them? 3, 2, 3. 1, 2, 3. That's where the y should be located. Therefore, intersection, that's our COM. Okay?